If I'm audible, kindly type yes in the chat box. Okay, thank you for the confirmation. So we'll be waiting for a couple of minutes for further attendees to join. So we'll start our webinar exactly at after 3 minutes. Thank you for joining the session on time. Okay. Um, Hello everyone. I welcome you all to the webinar on analysis and design of transmission towers using MIDAS Gen software solution. So to introduce about myself in brief, my name is Zulfiqar Ali and I'm working as a structural engineer at MIDAS. So basically I will be helping the clients who are dealing with high-rise buildings, bridges as well as the complex structures. So if you have any questions during the webinar, you can just type in the chat box so that we can discuss at the end of the webinar. Okay. So let's jump into the agenda of today's webinar. Like first, I will be giving a brief introduction about water transmission towers, and then we'll focus on the easy modeling, analysis, and design of transmission towers using MIDAS Gen software solution. And after that, giving a brief idea about MIDAS organization and what are the other software solutions that are available and the power users of MIDAS and few milestones that are achieved using the MIDAS software solutions. And finally, we'll conclude with a good discussion on queries. So basically, the transmission towers are nothing but the electrical pylons which are used to carry large amount of high voltage current. Okay. So nowadays the demand of transmission towers is very high. As you know, the electricity is one of the common basic need for the citizens. Okay. So there are a lot of infrastructure projects. So and one of them is like the transmission towers. So basically, these structures will stand a height of 50 feet to 150 feet. Okay, if we convert into meters, it will be like some 16 meters to 45 meters. And in few rare cases, the towers may have higher height. So tallest towers that are available is also at a height of 380 meters. Okay. So the basic factors that are governing for the height of the towers are like it required the minimum permissible ground clearance, that is H1. If this is our ground, and we required the minimum permissible ground clearance, and then these cables conductor wise are in tension, and it will be having the sulfate and other loads like wind and ice loads in some regions. So because of that, there will be sag developed in these conductors. Okay. So by considering the maximum sag that can occur in a cable, we can consider the height H2, and then the height H3, which will be the vertical spacing between the top and bottom conductors, and finally the height H4, which is a vertical clearance. Okay, so basically these vertical clearance will be from the ground wire to the top conductors. Okay, so this is our H4. So total height of our tower will be the summation of these particular heights. Okay. So with this basic idea on the transmission towers, we will be starting the modeling part. Okay. So basically, MIDAS Gen software solution can deal with the different types of structures like high-rise buildings and transmission towers. So first part of any project is the modeling. Okay. So here you have wide varieties of options where you can use the easy modeling. Okay. First one is like direct data transfer from any BIM softwares like Revit, Tekla. Okay. And second one is the text editor format. We can just enter the data in the text format and we can generate the models and we can make the modifications. And third one is the common type of modeling which is available in all the software solutions, that is using the node and elements. But today we will be more focusing upon the wizards. Okay. So the main advantage is like we will be having the standard wizards where we can just input the data and generate the model. Okay. And other functionalities like import from AutoCAD DXF and other structural engineering software solutions like SAP, STAD and ETABS. Okay. So today we will be using the most easiest approach, that is using the wizard. So in Midas Gen we have like customized tower wizard where we can input the basic data. So basically it is classified into three components. Okay. First one, at the bottom part we'll be having the tower legs, okay, with the different configurations, and middle part the tower body, and at the top we will be having the tower arms. Okay, so we can just select different configurations that we will be seeing in the demonstration part. So once we enter this basic data, we can quickly generate the towers of different configurations. Okay, and then we can apply different types of loads, more specifically like the wind loads and the seismic one. So now let us jump into the Midas Gen software solution and let us see how we can easily generate this particular model. Okay, basically this is the graphical user interface, like how Midas Gen software solution look like. Okay, so here we'll be having ribbon menu where it is arranged as per the workflow of the project, and two tree menus where we can easily find out the input or data of these particular models and we can modify easily, and message window, if there are any errors in the modeling it will be highlighted at this particular part. Okay, so Today we'll be focusing on how to generate this particular model and apply the loads and finally do the design. Okay. So basically, first we'll start with the structure tab where we can find the wizard for different types of structures. Okay, like base structures for arches, shells, and next one is the tower, transmission tower wizards. Okay, so first we'll start with the tower legs. Okay, and at the bottom we'll be having the status bar where we can dynamically adjust the units as per convenience. Okay, so if you are convenient in kilonewton and meter, we can adjust these particular uh, unit systems. Okay, now we will be entering this data one by one based upon the JD that is available for us, like what is the base width required. Okay, so first we will be having the number of legs. We will be considering 4 legs, and based upon this guide diagram, we can enter the inputs here. Okay, so here W is the width of the tower at the top of the leg, tower leg, and at the bottom we will be having W1. Okay, which is exactly half of the distance from the support location to the mid of that particular tower. Okay. So these annotations are can be easily understood from these guide diagrams. Okay. Now let us say for first leg, the width at the top from here to here, let us consider as 5 meters. Am I audible? Please let me know in the chat box. Uh, Sorry for the interruption. I got few messages that like sound is not audible, uh, but few of them has confirmed that sound is audible. Please check your audio settings once again. Okay. So anyhow, the session will be recorded for your future references. But kindly check your settings, audio settings. Yeah. Let's move ahead now. Like basically, here we will be selecting the leg numbers. Okay, and W is the height at the tower leg top. Okay, so that we are considering as 9 meters. Okay, and at the bottom we will be considering as 5.5 plus 5.5, that is 11 meters. Okay, W1 will be your half of the tower base leg base width. Okay, so we will be entering the data here, like a total width. Now for example, we are having 5 meters, then we will enter as 5 here W, and number of panels. Okay, so basically here we will be having two views. One is the front view and other one is the plane view. Okay, so here we can adjust the number of panels we are required. Okay, so by default here we will be having 5 panels. Okay, now if you want to further reduce the number of panels, we can just reduce the number of panels. Okay, so now we are considering 3 panels here, and W1 is half of the tower leg width at the bottom location. Okay, so that will be giving us 2.75, and W2 will be exactly half of the W. Okay, so that will be 2.5 meters. Okay, and similarly H is the height of the tower leg. Okay, now we are considering the tower leg height as 4 meters. Okay, so this is the basic information that we need to provide. W, the height at the top of the tower leg, it means at this location. Okay, and number of panels at this location, and W1 is the half of the bottom width location. Okay, and W2 is half of this one, that is 2.5, and finally height is 4 meters. Okay, so once I just click on modify, we can see the updated guide diagram. Okay, so we have total 3 panels. Okay, and plan view will be having these things. Okay, and same thing we can edit for the remaining legs one by one. Okay, so this is the first leg that we have modified. Similarly, we will be modifying the second leg. Width will be 5 and number of panels will be 3, and W1 will be 2.75 and W2 will be 2.5 and height will be 4. Okay, and we can also define the boundary conditions at the bottom of the tower leg, whether we want to go for pin condition or none, or even after generating the model we can modify the support conditions. So the advantage of these particular customized wizards is like we can also modify the data after the generation of the model as well. So we'll just hit on modify here. So in this way we'll be having the second leg, and similar pattern we go on editing for the remaining legs, that is leg number 3. Number of panels and height will be 2.75 and 2.5 and 4. Okay, so and finally the fourth leg, the number of panels are 3 and 2.75, 2.5 and 4. Okay, and we will modify. Okay, so once we have entered the data, and we can also go for different configurations that are available for the uh, bracing members. Okay, so here you can see different bracing patterns that are available for the front view as well as the top view. Okay, and here we can mention the insertion point. Okay, so basically we want this insertion point at origin, so we'll give as 0 comma 0 comma 0, and we'll hit on apply. Okay, so within few seconds, like your tower leg will be created here based upon the configuration that we have entered here. Okay, if you go for this manual modeling, it will be taking consuming some time, okay, to find out these particular coordinates and connect it manually. Okay, so next one is like the tower body wizard. Okay, so now we can create the body for this particular tower. Okay, we have different configurations. Okay, first one is like we can go for horizontal, that is like which is acting like a diaphragm for this tower leg top, and again in that we'll be having different configurations. Okay, so we can select the configuration as per our requirements, and we can also mention the w1. Okay, so now w1 will be the width at this particular location. Okay, and we can also check these distances with the help of query nodes option. Okay, if we select two nodes, the software will automatically provide the distance between the two nodes. Okay, so now we will be entering the w1 as 5, and similarly w2. So w2 will be, we want to vary the height from 5 to 2.5. Okay, and in the horizontal direction, like we want this particular pattern. Okay, and then we can just click on add, so it will be creating this particular diaphragm at this particular location. So just I will save this model. Okay, and then we'll go for the vertical configurations. Okay, so now in the vertical, again we can select the pattern that we require. Okay, whether we want to go for v bracing or inverted v bracing or the cross. Okay, and another interesting part is like we can also add the row of redundants. Okay, so basically these redundant members are additional members which help us in the stability point of view. Okay, and here we can mention the height of this particular each tower body. Okay, so basically for this configuration we will be adding 3 meters, and we can click on add. Okay, and similarly again further 3 meters we can add, so we can go on adding the height. Okay, for example, if there is any variation in the height, we can make the modification as well. Okay, so here for example we want 3.75, we can make the modification and we can add the height. Okay, and similarly again if you want the diaphragm at this location w2, again we can add the horizontal one. Okay, so in the horizontal we can select the configuration again here and we can add it. Okay, so in this way we can select the tower body, and then we can have the insertion point. Okay, so here when we click on this particular insertion point, it will having the green background so that we can easily click on the node where we want to insert it. Okay, so it will automatically update the coordinates of that particular point. Okay, and then we can hit on apply. Okay, so here we have created this particular tower. Okay, and similarly then next we can go for the tower arms. Okay, so in the structure we'll be having tower arms, and where we can again enter the data here. Okay, so here the width location is 2.5, and it will be varying till 2 meters. Okay, so we are gradually reducing the width of this particular tower. Okay, and again we can have different configurations. Okay, in the front view as well as the plan view, and then you can use the arms. Okay, sometimes there will be only left arm and sometimes there will be right arm. Okay, so based upon our requirement you can select these options for the left arm and right arm, and select the number of panels, and we can also select the pattern. Okay, and we can also mention the what is the length of that particular arm. Okay, let me take 5.565, and height of that particular arm will take as 2 meters. Okay, and similarly we can also have adjustment in the bracing patterns. Okay, so we can go for different bracing systems. So we can select different bracing systems as per our requirement. Okay, so same thing, we can update the data for the right arm. Okay, so this is 2 meters. We can take 2.5 as well, and length as 5.565. Okay, so once you are entering this particular data, so the software will automatically give the updates in of this particular configuration here. Okay, so that we can make confirmation before assigning it to this particular location. Okay, so now just we'll select this particular insertion point. Okay, and we can also rotate our model so that we can easily find out that particular point at the top. Okay, so here I will be selecting this particular top location, and these are the coordinates. Okay, and we can just hit on apply. Okay, next, similarly we will be having certain cage at this location and followed by the another tower arm. Okay, so we will be creating a cage here, so where now current width is 2 meters, and further we will reduce it to 1.5. Okay, so for cage we will not be having any arms on the left side as well as the right side. We will be having simple cage which is varying from W1 to W2. Okay, and now again we will be providing the insertion point for this particular tower. Okay, so I want to give this leftmost corner. Okay, so I can just, this is our isometric view, and we can just select the top point. Okay, so that is -1 and 21.5, and we can hit on apply. Okay, similarly one more tower arm we are going to create. So now the current width is 1.5, just we'll copy and paste it here, and further we would like to reduce it to 1.25. Okay, and again different configurations, and the arm data will remain same with the 3 number of panels, and length of the arm as well as the height of the arm, and we can hit on this insertion point here and apply. Okay, so in this way we can create the transmission tower model with the different configurations for the tower arms, tower legs as well as the tower body in different configurations. Okay, now we can easily check what are the things that are included in our model with the help of workstream menu. Okay, so here we can see the different types of elements, the material properties, and the sections that has been given by the wizard, as well as the pin support conditions that are applied here. Okay, so if you want to make any modifications, we can make the modifications easily here from the tree menu. Okay, so now let us say if you want to add a new section, we can always go to the properties and we can update the section properties. Okay, and we have standard database as per different codes. Eurocode we will be selecting UNI, and we can select any of these section here. Okay, so the best part is like we can select any cross section now. Later on, once we do the design, the software will suggest as the most optimum section for the design. Okay, so now let us take some random section of angle, and we can just apply this particular section to this tower. Okay, and when we are creating this particular model, the software will create some groups. Okay, so like the redundant member groups, main post, main bracings, arm ties, arm post, as well as the arm diagonal members. Okay. So accordingly, we can assign the different section properties for the different members. Okay. Now, so if you want to make any further modifications, we can create using node and elements tabs in the modeling, and material properties as well as the section properties, boundary conditions. And next part is the application of the loads onto this particular model. Okay. So the basic types of loads that are acting on the tower are the self weight, which comes under dead load, and some maintenance load, which will come under the live loads, and similarly the wind load in different directions. Okay, so wind X, that is wind load on the structure, and wind Y, wind load on the structure. Okay, and along with that we can have the seismic loads and other types of loads, broken wire conditions and all these things. Okay, so we can just apply the self weight here by considering the load case name and the factor, and we can add it here. Okay, and we can also change the element properties easily with the help of change parameter option. Okay, so here we can easily change the parameters like materials IDs, section IDs, and the element types. Okay, so here we can also change these particular truss elements to the general beam elements. Okay, and similarly we can also go for tension only elements for the cables. Okay, and the most important thing coming to the transmission towers is the application of the wind loads. Okay, so here we can generate the story data. Okay, so basically if you see the distance at the bottom, it is at -4. Okay, so just we will make the ground level as 0 for this particular tower. Okay, so we can just select all, and we can just translate the nodes along the upward distance of some 4 meters and hit on apply. Okay, so we can easily move the models. Okay, next one is like the story data. Okay, so these story data will help us to apply the wind loads. Okay, so in story data we can automatically generate the story data. So what this exactly does is it will find the nodes at different height locations, and it will create a story so that we can easily apply the wind load. Okay, so as these particular transmission towers are open structures. Okay, so here we will not be having the rigid diaphragm. Okay, so in buildings we will be having the rigid diaphragms. In transmission tower we will not have such type of rigid diaphragms. Okay, so for that we can just do not consider this particular 4 diaphragm option. Okay, next coming to the loading part, for lateral loads we have wind, air pressure, wind pressure, as well as the seismic loading conditions. Okay, so if you see for the wind load, we can select the load case name and as well as the code. Okay, so we will be applying the wind load as per Euro code. Okay, and we can also select different standard codes as per a requirement, as well as the national annex. Okay, and here we can apply the wind load parameters based upon the site condition and the project location. Okay, and basically these story loads are considering as 100% closed structures. Okay, but basically in transmission towers most of the parts are open. Okay, so for that, first initially we will calculate the solidity ratio, like what is exactly the obstruction area and the gross area. Okay, and accordingly we will be getting the ratio for the solidity. Okay, So that solidity ratio we will be just entering in the scale factor. Okay, so let us consider for this tower we are having solidity ratio of 0.15 in the x direction. So initially we are applying load in the x direction, so y direction factor will be considering as a 0. Okay, and then hit on OK. And similarly we will be applying the wind load on the y direction. Okay, so the remaining data will remain same. Now the solidity ratio will update in the y direction. Okay, so here you can see the software will apply the wind load onto the transmission towers. Okay, now for example, if you want to apply the wind loads, we have different patterns here. Like if you want to apply only on the face of a particular tower, in that case we can use different options like function wind pressure. Okay, so we can initially define the wind pressure function. Okay, so based upon the codal requirements, we can just calculate the wind. Okay, so our wind mostly depends upon the height of that particular structure. Okay, so we'll be having the mean wind speed, which is depending upon the CRZ factor. Okay, which is terrain and orography factor. So that will be given using this equation, which is depend upon the height Z. Okay, and then turbulence intensity and all these things. Okay, so basically we will customize this thing into a standard equation. Okay, so this is the standard equation for the wind load after normalizing this equation, so which is finally depending upon the height Z. Okay, so just we'll enter this particular equation here. Okay, at the last we will be entering the solidity ratio 0.15 and we'll give the function name as wind. Okay, and then we'll enter the height location here. So the tower is starting from height of 0. So the reason why we shifted up is here we are finding a function of logarithm. Okay, as it cannot take some negative values, so we have moved the tower to the top in the positive. Okay, so just we'll take 0.1 and end as 30.25, and increment we can give every increment as 1 meter or 2 meter as per our requirements. Okay, so once we hit on calculate, based upon these particular equation, the software will calculate the wind pressure at different heights. Okay, we'll click on OK here, and then we will be applying this particular winch load onto the face of these particular towers. Okay, so for that we'll just go to the function wind pressure and we'll select the direction. For example, if I want to apply in y direction, we can select y, or in x direction you can select x. Okay, in x direction the angle will be 0 and function is wind, and we will select the elements. Okay, so either we can apply it to the frame elements or the planar elements. Okay, so we will just select the edge of these particular elements. Okay, so this will be very easy with the help of select by polygon feature. Okay, so any complex shape can be easily selected with the help of this select polygon feature. Okay, so we can activate this particular part and we can select these elements and we can apply the wind load on this particular thing. Okay, so basically like here we will be having the closed connections. So for example, if you want to make any modifications in the model, we can easily modify the model as per requirement. Okay, so for example, if you want to make this particular thing closed, you can just easily create the elements at this location. Okay, so now we are not applying any wind on these particular bracing sections, so we will be selecting that and we'll make inactive. So we can activate and inactivate the sections very easily. Okay. So here we have inactivate option, so that we can easily inactivate this one. Okay. And we can select all these things, and we can apply the wind. So these feature will be helpful when you are having the complex shapes at the outer part of this particular any structure. Like if you are going for any complex stadium structures, so in that case, applying the wind load is a little bit typical. Okay, so that can be made easy with the help of these wind pressure functions. Okay, so here we have created the closed regions so that we can easily apply the wind loads along these things. Okay. So here we'll be selecting the elements, and we'll select all the elements and we'll hit on apply. Okay, and similarly for the other direction we will select in the y direction. Okay, and we will be here entering the angle as 90 degrees. Okay, and then we'll select the planar elements and we'll hit on apply. Okay, and then comes different types of analysis. Okay, we can do the p delta analysis, buckling analysis, eigenvalue analysis. Okay, and the construction stage analysis. Okay, these construction stage analysis I will be explaining in the upcoming slides. Okay, so these are all things that we can do in the modeling part. Okay, so basically now I will show the model where I have already created all these things. Like I have added the eigenvalue analysis. Okay, so we can see the number of mode shapes till 15, and I have given different sections for the main post, main bracings, arm ties. Okay, and redundant members. And here we have applied the wind loads. Okay, so basically here you can see the wind loads we can apply in different pattern. So here if you want to apply it one phase of this particular section, so that can be done with the help of wind pressure function. Okay, so these feature will be mostly useful when you are having the complex geometries where all the elements are not in a single plane. Okay, and similarly the seismic loads, we can also apply the seismic loads acting on the structure in the x direction as well as the y direction. Okay, and we can also apply the loads due to the cables. Okay, the conductor wide loads can be applied here. If they're exactly straight, we can apply in the perpendicular direction. So if they are in any inclined direction with certain angle, we can resolve it and apply the forces in two different directions. Okay, so once we perform the analysis, then we can check the results. Okay, so in results, we can auto-generate the load combinations in general tab to check for different combinations, as well as in the steel design to do the design of different members. Okay. So in general tab, when we auto-generate the load combinations as per the code. Okay. So here we will be creating the load combinations, including the envelope case as per Eurocode, and we can also add the response spectrum scale up factors. Okay. So after generating that, you will be getting two envelope cases that are generated by software. So in the strength envelope, you will be having all the strength load combinations, and in the serviceability envelope case, you will be having all the serviceability load combinations. Okay. So now you need to check results for each and every load combinations. You can directly check for the strength and serviceability. Okay. So now let us check the reactions. So in the reactions, we can select the envelope case, that is for strength envelope case, and maximum forces Fx, Y and Z. We can also check the values, and another interesting part is the legend. Okay, so in this legend we will be getting the summary. Okay, so we can change the units here. We are interested to see in kilonewtons as well as a meter. Okay, so here the software will give what is the maximum reaction that is coming onto our structure. So the maximum vertical reaction is 575, and horizontal forces are Fx and Fy are 113 and 71. Okay, and it will also highlight the location where exactly you are getting the maximum reaction. Okay, so we are getting at 33. Okay. So if you enter 33 in the node number, okay, so this is the node number 33, and it will also highlight with the help of some red color arrow which will represent the maximum thing. Okay, so if you want to add such images into the report, we can easily add with the help of dynamic report image. Okay, so we can just give the name for that particular figure reaction, so that it will be easy with the generating the reports. Okay, and similarly the deformations, that will check for the serviceability envelope case. Okay, so exactly how the deformation of the structure is taking place for all the load combinations. Okay, and here you can see the maximum deformation that is occurring onto the structure along with the units. Okay, and similarly we can see the beam diagrams, so like what is the maximum movement that we are getting into the particular model, that will check for the strength envelope case. Okay, so My is the moment and Fx is the axial forces, and Fy and Fz are the shear forces with respect to axis. Okay, so next interesting part is when we are dealing with such type of slender structures, we need to also check for the different mode shapes, how exactly our structure is behaving for different modes. Okay, so in mode 1, this is a deformation, and mode 2, so mode 2 mass participation is mostly along the x direction. So in the legend you can see in the second mode the mass participation is 51 percentage. Okay, so similarly in third mode the mass participation is maximum in the rotation z direction. Okay, so in this way you will be getting the detailed results. Okay, to interpret different mass participations along with the frequency as well as natural time period. Okay, and here we can also see multiple modes in a single window. Okay, so let us see. Now I want to see four first mode shapes, so I can just click on OK. So here we can see the different mode shapes. Okay, first mode behavior and second mode, third mode and fourth mode behavior. Okay, so we'll also see the buckling mode shapes of this particular tower. Okay, and we can also extract all the results in the tabular format. Okay, let's say if you want to design the foundation, we can take the reactions of this particular model. Okay, and here we will be selecting the envelope case for which we want to do the design, so maximum and click on OK. So all these tables are Excel compatible. Okay, so we can just right click and export to the Excel sheet. Okay, or we can easily copy paste the data from the tables to the Excel. Okay, so these we will be further utilizing for the foundation design part. So next we will be going to the design. So in Midas Gen we can do the design for steel. Okay, and RC design, SRC and cold form steel design as per Eurocode 3, and RC design as per Eurocode 2, and steel design as per Eurocode 3. Okay, and just we can go for different parameters. Okay, so basically when we go into the design part, so few useful features are like the software will automatically calculate the effective length factors. Okay, which will be utilized in the slenderness calculation. This effective length is calculated based upon the stiffness of the connecting members. Okay, and we can also give different general parameters like the limits for limiting slenderness and effective length factors, unbraced lengths. Okay, equivalent moment correction factors, and we can also do the stress checks as well as the deflection checks. So these are the different available codes. You can use Eurocode, and for seismic design, we can also include Eurocode 8, and we can also use BT standard codes, RC design BS 8110, and for steel, we can use BS 5950 2000, the latest code for steel design, and similarly for the other designs. Okay, now let us see the design part in the software. So once we enter these particular parameters like slenderness ratio for compression members as well as the tension members, so we can select all and we can apply these limits for the compression and tension members. Okay. Similarly, the equivalent moment factor, whether it to be calculated by the program itself, we can select all and we can hit on apply. Okay. So similarly, different parameters can be provided here, and then design code. Okay, so we can select Eurocode and we can also apply the special provisions for the seismic design as well. So next, we can enter the serviceability parameters. Like if you are interested in the deflection checks, we can select all these members and we can provide the deflection checks. Okay, now we can do the steel design. Okay, so we can do the design of all the members at a time, or we can select certain members and we can do the steel code check. Okay, so if you want to see if any of the members are failing, we can just click on NG so that it will highlight if there are any failed members. Okay, but if you see here, the utilization ratio is very less. Okay, because we have selected a smaller section. Okay. So in MIDAS Gen, we have option of steel optimization. Okay. So initially the section is utilized only 48 percentage. We can select these and we can do the optimization. Okay. So here we can select what type of section we want. Okay. And then hit on search satisfied section. Okay. So the software will do iterations and it will suggest few sections that are having good utility ratio along with the cross-sectional area. Okay. So if you want to reduce the weight, we can go for some lesser cross-sectional area with good utility ratio. Okay. So we can select it and we can change this section. So the new section will be having utility ratio of 84 percentage. Okay. And we can also update this particular section to our model. Okay. So we can select this particular section and we can update it. Okay. So in this way, we can make the steel optimum design sections. Okay. So once we have done the design part, now we can generate the report for this particular model. Okay. So we have some special tools like MGT command shell for text editing. Okay. And design plus tool. Okay. So basically this design place will help us to deal with all the individual components. Okay. So basically in design place we can go for different individual component design. If we focus on the transmission tower, okay, so we can do the design of the base plates for the tower legs, and then anchor bolt design and footing designs. Okay. And similarly we can go for other types of connection designs. Either we can go for bolt connections, shear or moment. Okay. So now let us see like how we can easily generate the report of this particular model. Okay. So in tools, we can use this generator option, like where we can open the design report that you usually create submit to the clients. Okay. So this is the sample report. So this report is in use. Just let me close that report. So basically, here we can open our existing Word document within the software. Okay. So basically here you can have your descriptions and all the contents and logo of your organization and the basic data here, like different inputs that we have provided. Okay, and what are the load cases that you have considered. Now interesting part is, like for every project we need to add the images for the 3D models as well as the results. Okay, so this is one of the report for two tower model. Okay, along with the cables. Okay, so which is already created for the past project. Okay, along with the sections that you are utilized in the model. Okay, for tower legs as well as these things. So where you are having the results images, like beam stresses, shear force diagrams and all these things. Okay, now for the next project we need not to worry about what are the images that we need to take here. Okay, so we can just import that particular images from our previous model file. So all these images will be updated here. Okay, so only thing that we need to do is we need to regenerate the report by just one click on regenerate. Okay, so the software will automatically replace all the model images along with the results as per our current project. So you can see here, now the axial force diagram has been updated and the shear force diagram also has been updated, stresses as well as the bending moment diagrams. Okay, and you can also see the reactions. Okay, so even the reviewer can easily understand, like what is the maximum reaction we are getting and what is the location and what is the load case we are checking it. Okay, so we are checking a dead load and these are the maximum reaction values. Okay, so in this way you can quickly update the reports. Okay, in a customized format. So you will be having the report as small as possible as per customization. Okay, unlike some other software, it will be giving lot of number of pages, that too in the PDF format, which cannot be edited. Okay, okay, next we will be seeing the design plus tool. Okay, so one example of footing optimization. Okay, so initially we don't know exactly what is the footing size required for our tower. Okay, so basically we can link this particular model to the MIDAS Gen model here, and here we can design different types of components. Okay, so now we are interested in the footing design, like isolated footing, and we can also select the codes. Okay, so we are more interested to design as per the Euro code. We can change the code for the rebar as well as the design. Okay, so here we will be having the footings. Okay, we can add the footings here. Okay, and we can input the material properties as well as the section properties. Okay, and we can also add the load combinations, service load combinations as well as the strength load combinations. Okay, so already we have got some reactions. We can just directly copy these reactions from the Excel and we can paste it here in the load combinations. Okay, and similarly we can also go for isolated mat or raw foundations. Okay, so initially we are assuming 3 meters by 3 meters. Okay, and we have option of design optimization for different types of sections. Okay, so basically here I will select the footing, maximum thickness will go till 2 meters, and okay. So once I click on design, the software will automatically suggest like what is the size required. Okay, so this is major advantage in the foundation design. Okay, so I need not to go for 3 meter by 3 meter. The software will suggest like 1.4 by 1.4 is quite sufficient for this particular foundation. Okay, not only design, it will give the detailed report along with the calculations. So always we can go through these detailed calculations for the confidence. Okay, and we can also generate the drawings in one click, where it will give the template in a quick summary, like what is the length required and thickness required and the rebar arrangement. Okay, So we can also save these as a DXF file, and we can also make modifications as per requirement, or we can make the modification here itself by entering the basic commands related to the CAD. And another interesting part is like it will generate the quantities as well for the footings. Okay, so here we can just hit on create, so you can also dynamically change the units as well. Okay, so we can go to the initial registry, and here we can also select the unit systems for reports, database, okay, as well as design codes, as well as a batch design. So here we can see the amount of concrete required for our project, the foundation, and then the rebar. Okay, so for rebar one, what is the weight required in newtons, and some of the weight in the x direction as well as y direction, and total weight. Okay, so in this way we'll be getting the quantity of both concrete as well as steel. So in the same way, we can go for the design of different elements like base plates, okay, bolt connections, and movement connections. Okay. So here we can go for shear connections, okay, and splices. Okay. So in transmission towers, like we will be having a lot of splices joints, that also we can consider here. Okay. So this is brief about the design place. So now let's have a brief idea about like MIDAS. Okay, so MIDAS is established in year 1989, and we have number one market share in MIDAS, like civil engineering software solutions. Okay, our headquarters is in South Korea, and we have 11 branch offices across the globe. Okay, so we are located in India, and we will be assisting clients that are in Africa, Middle East, and India, and along with that, most of the English-speaking countries. Okay. And these are the power users of MIDAS software solutions who are using our software for more than a decade, like Arrow, Paycom, Jacobs, and many more. And if we focus particularly on the Africa region, okay, so here we have users in the government organizations as well as private organizations. Okay, so like Kenya Rural Roads Authority, Kenya Highways, okay, UNDRA, Tanzania Rural and Urban Roads Agencies, okay, Ethiopia Municipality in South Africa, Aegis Kenya, okay, and some private users like ACOM, Zutari, Gibbs, Atkins, Oricon, JM Karuki. So they are using one or the other MIDAS software solutions. So today we have discussed brief about the MIDAS Gen and Design Plus. Like if your organization is also dealing with some other structures, infrastructure projects like bridges, so then we have some powerful tools like MIDAS Civil, which can deal with all types of bridges, and MIDAS FNX, which can deal detailed finite element analysis, where the plate modeling and solid modeling is required. And for generation of the drawings of these particular bridges, we have MIDAS CIM, where we can have 3D rendering visualization as well as generate the drawings with the help of MIDAS CAD Infra Design. So for any superstructure, we need like will be having a substructure which is underground. For that, we require some geotechnical analysis like soil structure interactions, okay, deep excavation, pile raft foundations. So for that, MIDAS GTS Annex can easily handle all these things. And finally, in mechanical, we have MIDAS NFX. It will be helping in dealing with some mechanical engineering related issues, as well as computational fluid dynamics for high-rise structures where wind tunnel test is required. So not only the transmission towers, MIDAS Gen can easily handle all types of buildings like RC, steel, composite, okay, and plant structures, airport hangars, Okay, complex stadiums, and column shortening analysis for high-rise structures, as well as post-tension as well as pre-tension analysis, machine foundations. Okay, so the dynamic analysis of machine foundations, heat of hydration analysis for mass concreting structures, and few structural safety checks like carbon fiber wrapping, okay, and jacketing. So these are the few iconic projects where MIDAS Gen software solution was used for high-rise structures, Burj Khalifa and Jeddah Tower column shortening analysis, and in steel structures like Beijing Olympic National Stadiums and German Pavilion, where the dynamic analysis like response spectrum and steel optimization is utilized. And the twisting tower with composite columns as well as the masonry structures, and we can also easily handle the elevated metro stations as well as underground metro stations. Okay, so before winding up, just I can show some advanced features of the like further applications of these particular transmission towers. Okay, so in transmission towers, basically we will be having like a cable break conditions. Okay, so here we can also go for the construction stage analysis. Okay, so here you can see in stage 1 we will be having one tower, and stage 2 we have constructed another tower. Okay, and in stage 3 we will be having the cables at this particular location. Okay, so we can also go with the detailed construction stage analysis for these towers, and we can also simulate like if there is any break in the wires. Okay, so here in the stage 4, if there is any break in the cable, so we can break that particular cable and update the redistributed forces to the tension these remaining cables and apply the impact force for these cables. Okay. So in this way we can go for the detailed construction stage analysis. Okay, and along with that we can also see the buckling mode shapes of this particular tower. Okay, so if there is a chance of failure in tower for the buckling of the slenderness issues, so we can check the buckling mode shapes. Okay, critical locations, and then we can also update the model for the imperfection analysis. Okay, if you want to do further analysis on the deformed shape, we can update the model here. Okay, so that it will create a updated model for the uh, imperfection analysis. Okay, so this is brief about like a transmission tower modeling analysis design as well as the report generation using MIDAS Gen. Okay, so apart from this, we can also go for some different types of structures like uh, guide mast towers as well. Okay, so in towers we can deal with different types of towers. Even we can also model some guide mast towers as well as some vertical towers. Okay, so this is brief about from my side, and if you have any questions you can just type in the chat box. I will answer one by one. Okay, so like I will start with first question. So do you have anything that interpret CPT data in geotechnical analysis? Okay. So for detailed geotechnical analysis, we can use another software solution, that is MIDAS GTS-NX. But if you are having any data related to the soil, always we can simulate using the different spring conditions. Okay. So you can also input the stiffness values that we are getting from the geotechnical data. Okay. The stiffness in different directions. And we can also apply the pile springs based upon the type of soil that is there, like soil, sand, soft clay and stiff clay. Okay. uh, Regarding the sands code, like if we go for the material properties, like we can select see different codes that are available. So right now we have American standards, Euro codes, British. Okay. So like sans code, we are planning for the including these particular sans code for materials as well as section properties. What about the connection design? Okay, so basically design place can handle like bolt connections. Okay, if you see in the steel, we have bolt connection. In bolt connection again, we can go for like shear connection or moment connection, as well as the girder splices, column splices. Okay, like if you want to go for some advanced connection design, so in midas gen we have option of exporting this data as a idea file or idea steel connection. Okay, so where we can just export the entire model of steel design to idea statica, where we can do any type of complex steel connection designs. If it is a basic connection design, bolt connection, that we can do in the design phase itself. uh, which analysis did you perform for this tower under consideration? Okay, so basically like for the tower, basic analysis are like we will be going for the linear static analysis as well as a buckling analysis to see the buckling mode shapes. Okay, and if you want to go for some detailed analysis like cable break conditions and all these things, we can simulate the construction stage analysis. And apart from that, we can also go for p delta analysis, eigenvalue analysis. Okay, and even we can also perform some detailed nonlinear analysis. Which pressing pattern is most cost effective and perform best on wind loading? Okay, so predicting the bracing pattern, it mostly like it is a R&D topic where we need to do some different iterations, but still we can find lot of research papers online by making study on different bracing patterns. Okay, can we design suspension or tension cables for structures, especially for the suspension bridges or guide mast poles? Okay, so for bridges, as I mentioned, like we have dedicated software, that is Midas Civil, where you can dig easily with suspension bridges, and you can also find the forces that are present in the cables. And same thing in these cases also, like in loads, we have one option in pre-stressing, like pretension loads. Okay, so here you can model these cable elements. If you see create elements, here we have different options, like we can also model tension only elements as a cable, and where you can mention the LU length, considering the SAT, what is the length of that particular cable, or you can mention the pretension forces acting on that particular cable. Okay. And if you want to know the what is the tension, particularly like if you see in guide mast towers, okay, so if you want to find what is the tension required in these particular elements, so in that case we have one option, that is unknown load factor. Okay, so based upon the different constraints that we are providing in the model, so accordingly the software will provide the tension force that is required in these cables, so that the structure is satisfying the constraint conditions. Okay, so if you go for unknown load factor, so basically here we need to have one load combinations. Let just me provide one dummy combination. So here we can add the constraints. Okay, so either you can make some constraints, like for example displacement. Okay, so we can select this top node of this particular tower and mention that the horizontal displacement should be within this particular limit, 5 mm or 10 mm. Okay, in x direction and y direction. So based upon the constraints that you are mentioning, the software will suggest the tension forces required in this particular cable, so that you can do that particular pretension and anchor at this location. So this unknown load factor method like will help you to give the initial tension forces in the cables which are satisfying the uh, constraints. Yeah, we will be sharing the recording for your future references. How do you counteract the effects of overturning movements during the design? Okay, so in most of the cases, like these particular structures are having the pin support conditions. But if you still want to see the movements for different combinations, that you can see the movements in the you can create some load combinations. Okay, which are helping the structure to have stabilized, like dead load. Okay, and other load combinations like lateral loads which are trying to create the overturning. So these things we need to do little manually. How the tension force in power cables take into account, like when cable collapse due to accident. Okay, so basically when cable collapse, then what happens exactly is like there will be some redistribution in the forces. Okay, so for example, like initially each wire is taking some 50 kilonewtons and there are some three number of wires. Okay, now when there is a break in the cable, it will start to take the redistributed moment. Okay, so now each cable tension force will be updated to the 75, and there will be some unbalanced moment that is acting onto the structure. Okay, so that unbalanced force can be applied as a nodal load. Okay, so in static load cases, here we can select the nodal load, and here we can select that particular broken condition. Okay, so here we'll take the broken wire impact load as a user defined. So right now we are in the base stage and we will be applying the nodal loads by creating one case where we are having the broken wire condition. So we will consider that broken wire case, and here we will be applying that force, additional force, that is impact force. how much impact we are considering. Basically, the impact will be from 1.5 to 2 times. Okay, and we will be applying this force in the y direction. Okay, so basically this is in fy direction. So if the cables are in a different direction, in that case we can resolve these particular forces, and we can add the value in fx and fy direction. We have to perform all of them for the tower design. Okay, actually it depends upon the analysis, what type of analysis you want to do. Like if you want to do entire thing in a single model, then you can go for the construction stage analysis. So the best simplest thing is the linear static analysis. Okay, if you're satisfied with linear static analysis, is okay. Otherwise we can go for buckling analysis. As the structures are very slender, we can go for the buckling analysis. Okay, uh, it is up to the engineer's decision, like till what advanced level we can go, but we have all the features that are required for this thing. Okay, and another interesting part I have missed is like the detailed design calculation reports. Okay, so once you have done the design, you can also see the detailed calculation reports. Okay, like after doing the steel code check, you can see the detailed calculation reports. So exactly how the software is calculating the capacity of this particular section. Okay, so first the software will classify the sections, and it also specify the reference. Like if you go for 0 code 3 table 5.2, there is a classification of the compression flange. Okay, and the b by t ratio, and you can check what type of classification it is, like class 1 plastic for the flange, and similarly for the web it is class 4 slender. And calculate the buckling factor for outstand compression flange as per Eurocode 3 part 15. So in this way you will be getting the detailed calculation reports, so that an engineer get the confidence to verify these things. Effective section modulus about minor axis and the cross sectional properties of the flanges, and different checks like slenderness checks, axial resistance, okay, buckling resistance, shear resistance. Okay, so all the checks you will be having the equations, and exactly what are the equations the software has used to find out these capacities as well as the resistance. So this is the major advantage of the software, where you will be getting the detailed report, and you can also see a summary report. So this is only for the quick reference, like what is the slenderness ratio of this particular member, and what is the axial resistance, bending resistance, combined resistance. Okay, so you'll be having summary report as well as the detailed report. Okay, can the same be done in engine? Yes, you can also do it in engine, but midas gen is like advanced software solution. Yeah, I hope I have answered all the questions. Okay, in case if I have missed any of the questions, you can feel free to uh, contact us. So Once again, thank you so much for attending today's webinar. Okay. So finally, just I want to introduce our MIDAS support website. Okay. So in future, if you are having any queries, so you can just visit our MIDAS support website. So in MIDAS support website, you will be getting more information regarding like if you want any help, you can ask question here. You can ask question here, and if there are any updates, we will be frequently posting here, and we will be having interesting tutorials like for practice. Like we have different software solutions. Like if you are more interested in Midas Gen software solution, you can start practicing these particular tutorials. Like if you want to see any design of steel structure, you'll be having comprehensive tutorial where you'll be explaining step by step like how to create the material properties and all this detail. Okay. So a lot of resources are available on the Midas support website. Okay. So like tutorials and expert columns where we'll be having discussion regarding different structures. Okay. And products and product information, product manuals and support. Okay. And some academic courses. Okay. So you can always also get in touch with us, and you can explore our support website, and we also have MIDAS structure where you can see more interesting blocks. So like element rotations, flat slab designs. Okay. And different questions like wind loads as per ASC code, and nonlinear analysis, heat of hydration analysis, construction stage analysis. So you can find a lot of resources as well. Okay, thank you so much for attending today's webinar. See you in the upcoming webinars. Have a great day. Okay, I think there is new question like how to design ice loads in consideration, please. Okay, so basically like we need to calculate this ice load, and we need to apply it as a normal load, whether it is like a UDL or some concentrated loads. The effect of terrains in mountainous areas, like are you asking about the wind loads in these particular areas? The terrain categories and all these things that will be covered in the wind load application as per the Euro code. So as I've shown you earlier, like all there are always two flexibilities. One is like you can go with the code based loadings like wind loads. You can see terrain categories. Okay. And if you want to go for further details, like here you can see considering orographic effects and orography type, hills and ridges. Okay. And cliffs and escarpments, and consider the effect of neighboring high-rise structures, and all these things you can mention here, parameters for the mean wind velocity. Okay. And always here you have a flexibility to modify the factors here. Okay, it's always flexible. You can change the whatever the parameters you want to change here, or you can directly enter the force coefficient that is directly used for the calculation of the forces, or you can use the function wind pressure option. Okay, so here in the function you can either give a function, or you can go for user input, and you can input the wind pressure values at different heights by considering all the parameters. Okay, so based upon this wind pressure at different height location, the software will apply the wind loads based upon the elements that we are selecting. Okay, so if you select the frame elements at one location, so if you select these particular face, so that particular phase will be applying wherever there are nodes, it will be applying the wind load. So either you can go with code based, or if the wind pressure is changing, then in that case we can use directly input in the user defined option here. So that you can easily calculate by standardizing this equation. Okay, so after all these equations you will be getting some height locations, accordingly you will be getting the pressure values. Okay, so same pressure values you can easily just copy here and paste here. Or you can just make the modifications here. Okay, uh, I want to understand the drives, overturnings and frequencies. Okay, so basically after performing the analysis, as I was shown earlier in the results, we have vibration mode shifts. So we can check the vibration mode shifts for each mode, or we can also check in the table of format. Okay, so here you can check the frequency as well as the time period. So frequency of the first mode is 2.4810, and the time period is 0.4031 seconds. Okay, so here you can find the frequencies as well as the time period for the model analysis. Okay, and here you can see the mass participation. Okay, so the mass participation in 15 modes is around 83 percentage in x direction and y direction, and z direction it is 75 percentage. Okay, so if you want to increase the mass participation, we can increase the number of modes. Okay, that we can do from here in eigenvalue analysis. Instead of 15 modes, we can go for 20 modes and check whether the mass participation has been increased to more than 90% or not. Or for based upon the criteria, we can go on increasing the number of mode shifts. And coming to the story related results, in the results tables, we have story data where we can see the story drifts, okay, story displacement, and story mode shapes, story eccentricity, stability coefficients, and remaining checks. These are mostly used in the uh, buildings. Okay, and the overturning moment. Okay, you can select the overturning moment for, like, let's say a wind load case. So here you will be getting the overturning moments by vertical members. Okay, so this is the load, the story data and different levels, and these are the overturning moments for the vertical member types. Okay, so you can change the units to kilonewton meter. Okay, so these are the overturning moments at each story level. So you can see the overturning moments from here, as well as in the seismic load case as well. So when you are applying the seismic load cases, so before performing the analysis itself, the software will provide as the story shear along the height. So what is the maximum base shear coming onto this particular structure? Okay, base shear as well as the overturning moment due to the seismic condition. And we can also see the seismic load calculation sheet. So what are the masses and what are the parameters that you are considered and all these things. Okay, thank you so much for your interest. If you have any further questions, you can always get in touch with us. Okay. Once again, thank you so much for attending today's webinar by sparing your valuable time. Okay. In case if you have missed any queries or if you want to contact us further for the technical queries, you can contact ali@midasit.com, and for commercial related queries, you can contact sitaram@midasit.com. Or you can also visit our MIDAS support website, and from there you can create a ticket for get help. Okay.